Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Using GenAI to create diverse data scenarios. In the field of data engineering, the application of generative artificial intelligence to create diverse data scenarios is a transformative approach that enhances data augmentation and enrichment processes. This lesson delves into the practical applications, tools, and frameworks that professionals can utilize to harness the potential of GenAI in crafting varied and robust datasets. By leveraging GenAI, data engineers can address challenges such as data scarcity, imbalance, and the need for synthetic data generation, ultimately driving innovation and accuracy in data-driven projects. The primary advantage of using GenAI in data generation lies in its ability to simulate real-world scenarios that are either rare or underrepresented in existing datasets. For instance, GenAI models such as Generative Adversarial Networks have been employed to generate synthetic data that closely mimic real data distributions. GANs operate by pitting two neural networks against each other, the generator and the discriminator, where the generator creates data samples and the discriminator evaluates them against actual data. This adversarial process continues until the generator produces highly realistic data samples. The application of GANs has been particularly successful in fields like image processing, where they have been used to augment datasets with synthetic images to train more robust computer vision models. Beyond generating synthetic images, GenAI can be used to create text, audio, and video data scenarios. For instance, language models such as GPT can generate diverse text data that can be used for training natural language processing systems. These models are capable of understanding context and generating coherent and contextually relevant text, which can be invaluable for creating datasets that reflect a wide range of linguistic styles and expressions. Similarly, audio synthesis models like WaveNet have been utilized to generate high-fidelity audio samples that can be used to augment datasets for speech recognition systems. To practically implement GenAI for data scenario generation, data engineers can employ several tools and frameworks that facilitate the easy deployment of these models. TensorFlow and PyTorch are two leading open-source frameworks that provide comprehensive libraries for developing and training GenAI models. TensorFlow's Keras API, for instance, offers pre-built layers and modules that simplify the construction of GANs and other generative models. Similarly, PyTorch's dynamic computation graph feature is particularly useful for implementing complex models like GANs, as it allows for more intuitive model design and debugging. Key challenge in generating diverse data scenarios is ensuring the quality and relevance of the synthetic data. To address this, it is essential to incorporate evaluation metrics and validation techniques into the data generation pipeline. For example, the Fréchet Inception Distance Score is commonly used to evaluate the quality of GAN-generated images by comparing the distribution of generated images with real images. In the context of text generation, perplexity is a standard metric used to assess how well a language model predicts a sample of text. A lower perplexity indicates better performance. Real-world case studies illustrate the effectiveness of GenAI in generating diverse data scenarios. In the healthcare industry, for instance, synthetic data generation using GANs has been employed to create realistic medical images that preserve patient privacy while providing sufficient data for training machine learning models. A study demonstrated the use of GANs to generate synthetic mammograms that were indistinguishable from real ones, allowing for enhanced breast cancer detection models without compromising patient confidentiality. Similarly, in the autonomous vehicle industry, companies have utilized GenAI to simulate diverse driving scenarios, including rare and hazardous conditions, to train and validate self-driving algorithms more effectively. To successfully integrate GenAI into data engineering workflows, professionals must also consider the ethical implications and potential biases inherent in synthetic data generation. It is crucial to ensure that the generated data do not perpetuate existing biases or introduce new ones. This necessitates a thorough analysis of the training data used by generative models, as biases in the input data can be amplified in the output. Techniques such as debiasing algorithms and fairness-aware GANs can be employed to mitigate these issues and ensure that generated data scenarios are both diverse and equitable. In conclusion, the application of GenAI to create diverse data scenarios represents a significant advancement in data augmentation and enhancement strategies within data engineering. By leveraging tools and frameworks such as GANs, GPT, TensorFlow, and PyTorch, data engineers can generate synthetic data that address challenges such as data scarcity and imbalance while enhancing the robustness of machine learning models. However, it is imperative to incorporate rigorous evaluation metrics and ethical considerations to ensure the quality and fairness of generated data. As demonstrated by real-world applications in healthcare and autonomous vehicles, GenAI holds immense potential for driving innovation and accuracy in data-driven projects. By understanding and applying these concepts, professionals can enhance their proficiency in using GenAI for data scenario generation, ultimately contributing to more effective and equitable data engineering practices. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.